Okay, for 16, you're going to use the segment addition postulate, which just means it's these two small sections are going to be equal to the big section. So it's, no, I'm just going to do it. So 7x minus 8 plus 28 equals 5x plus 34. So it's going to be 7x plus 20 equals 5x plus 34. 20 equals minus 2x, you get 3x plus 34, and you subtract 34, you get negative 14 here, equals 3x. Odd. 14 divided by 3 is 4.67. So x equals negative 4.67. Let me make sure I did this right. 7x minus 8 plus 28. So that's going to be 20. Oh, it's a 7. Shoot. Here, that's 7. So this was minus 7x. So that's negative 2 here. Negative 2, negative 2. Equals negative 14. So that means x equals 7. Okay, that's better. So x equals 7. Let's test it. So you have 7 times 7 minus 8 plus 28 is 69. The top one's 69. 5 times 7 plus 34 is 69. This bottom one's 69. So it works. That's the answer. Exact circumference. So when it's asking for exact circumference, that's going to be the lazy way to do it. So exact circumference. C equals pi times diameter. Your diameter here is 20. R equals 10. Diameter equals 20. So the lazy way to do it, C equals 20 pi. That would be the answer. If you want the approximate, so 20 times pi, well, that's 6.28 something, something, something. No, 62.8. 62.8 something, something, something. 20 times pi. I'll just show you how I got that. 20 pi, 62.83. 62.83 is the approximate, but this is the answer it's looking for. Or 62.83 is what this says. Sorry. Draw and label a pair of opposite rays. Here's a ray. Let's say it goes from H to O, and then to make it opposite, so this is ray HO. Ray HO. And then let's send one this way. This is the opposite one. So that one is HR, ray HR. Draw, label, name. Possible names for the planes that contains AR. So this plane here, F is not even on the plane, so we're not going to care about it. So if you want to name this plane, I'm going to give you a few options here. First, you write the word plane. You pick 3 points that are on the plane that are not in a straight line. So WC, WC, I can't pick T because WC and T are in a straight line together. It'd be easier to see if I use something small. So WC and T are all 3 in a straight line, so we can't use T. You can use anything else, WCR. WA doesn't matter, WAC. AC are in a straight line, but the 3 of them are not in a straight line. Let's do RC. If you do R and C, you can't use A. So RCT. All these work. Line, segment. This is the length. This is a line. This is a ray. Okay, so this gives you a midpoint, and you have to find the other endpoint. So I'm going to use the snowman here because that's the method I like the best. -5, 8 is the head, 2, -1 is the body, and we're going to look for the butt. So -5 to 2, we increase by 7. So increase by 7 in, you get 9. 8 to -1, you decrease by 9. Decrease by 9 again, you get -10. So there's the answer here. That's increasing, that's decreasing. Cool. Find AB. So remember, this means the length. So that's going to be the distance formula. Distance equals, this is on the back, it's in the middle, it's red. x2 minus x1 squared plus y2 minus y1 squared. Okay, x1, y1, x2, y2. So distance equals the square root of -2 minus 11 squared plus 6 minus 3 squared. So this is going to be -2 minus 11 is -13 squared plus 3 squared. So that's going to be the square root of 169 plus 9. So square root of 178 is the answer. Square root of 178. Or you could also say 13.34. Acute angle less than 90. This is on the board. Equal to 90. Greater than 90, but less than 180. Feel free to skip ahead to when I finish this, because it's not that interesting. Straight angle equal to 180. Acute angle, that's an acute angle. Right angle, it's a right angle. Obtuse angle is bigger than 90. And then a straight angle is a flat line. Just pretend that's a flat line. Define and draw an example. Complementary equals 90 degrees. When angles add up to 90 degrees. Equals 180 degrees. Linear pair is supplementary and adjacent. So they're touching and they're supplementary. They're touching and they add up to 180. Vertical angles, when there's an x, they're the angles that are across from each other. So these two are congruent. You also have these two that are congruent when they're across. Linear pair looks like this when there's a pair. These two are the linear pair. Oh, shoot. Put it over here. So these two are the linear pair right here. Supplementary, they can be adjacent or non-adjacent. So this is an example of supplementary. You can also have where it's like this is 100 and then this is 80. These would technically be supplementary. Complementary, if you have these two angles are complementary. You can also have like angle 1 equals 89 and angle 2 equals 1. These two would be complementary also because they add up to 90, obviously. Okay, one more video to get the rest of this done.